Before we wrap up the course, it's important that we touch on use cases and possible consequences of the flyweight pattern in more depth. First off, like all design patterns, implementing every class in your project as a flyweight is not the way to go, and can even be overkill and clutter up your codebase. Seek out the places where it really makes sense to use it and use it correctly. Some common scenarios include when an application needs to have a ton of objects, which makes storage cost an issue. When object state can mostly be turned into extrinsic state, and many groups of different objects can be generalized into a few shared ones. When the application doesn't depend on object identity. Flyweight objects are shared, so identity tests will not be able to distinguish between shared references. The main implication of the flyweight pattern is memory usage, and more specifically storage savings. However, these need to be understood a little better to see the benefit at different levels of usage. Now, there are going to be some runtime costs that play a part in finding and computing a shared object's extrinsic state. If applied in the correct situations, this is going to be offset by the space savings from each additional shared flyweight object that you use. Savings will then be at their maximum capacity when lots of shared objects are used and both stored intrinsic and computed extrinsic are substantially used. Hierarchical relationships and communications can still be used by passing references to a parent or other hierarchy objects in with the extrinsic state. We should note here that the composite pattern is a great way to create logical hierarchies that need to coexist with the flyweight pattern. It's also good to keep in mind that state and/or strategy pattern implementations also work well for the flyweight objects themselves. In summary, we've learned how to create a flyweight interface and concrete classes, how to distinguish and implement intrinsic and extrinsic state, how to use a flyweight factory correctly, how unshared flyweights fit into the pattern, and finally, how to identify and work with the pattern in real-world scenarios. I hope after all this you've come away with a real grasp of the flyweight pattern and how it can save you memory headaches in your own projects. If you're interested in more design patterns with C#, we have a whole curated course list in the Pluralsight library. If you've enjoyed the course, please go ahead and leave a course rating. And if you have any questions or comments, the discussion section is always open and I monitor it all the time. If you just want to connect and talk code, that's good too. Give my author profile a follow and drop me a line. As always, happy coding.